According to the 2020 National Electrical Code, specifically in EC Article 250.24b, a grounding electrode conductor shall be installed with each feeder or branch circuit that has phase conductors. However, there is an exception, where the feeder or branch circuit supplies only one building or structure served by a single service, and where the supply conductors terminate at the meter or other approved service equipment that is grounded, the grounding electrode conductor may be run with any one of the supply conductors. Furthermore, NEC Article 250.104 states the grounding electrode grounding conductor or conductors shall be connected to the equipment grounding conductor at the service equipment. There is an exception to this as well, where the grounding electrode conductor is connected to the neutral conductor at the service entrance equipment, and the grounded neutral conductor is effectively grounded at each building or structure served. A grounding electrode conductor is not required to run with the feeder from the service equipment. In your situation, if you are using Ufer ground at the house and garage and grounding the neutral at the subpanels, you are not required to run a separate ground wire with the feeders. However, the Ufer grounds must meet the requirements of NEC Article 250.52 for proper grounding. This article outlines the requirements for concrete encased electrodes, often referred to as Ufer grounds. These requirements ensure that the grounding electrode is effective in providing a low impedance path to ground. The neutral conductor must be effectively grounded at both the house and garage subpanels. This can be achieved through a separate grounding electrode system at each structure or by ensuring the neutral is properly bonded to the Ufer ground. It is important to refer to the specific local electrical code requirements in your area for any additional or more stringent regulations that may apply. Local codes can vary and may have specific amendments or interpretations that differ from the national code. Understanding the NEC and local electrical codes is crucial for ensuring electrical safety and compliance. These codes provide detailed guidelines on grounding, wiring, and other electrical installations to protect people and property from electrical hazards. Improper grounding can lead to electrical shock, fire hazards, and damage to electrical equipment. Firstly, let's examine NEC Article 250.24b in greater detail. This section emphasizes the importance of having a grounding electrode conductor for each feeder or branch circuit. The grounding electrode conductor connects the equipment grounding system to the grounding electrode, such as a ground rod, ground plate, or Ufer ground. This connection provides a path for fault current to flow back to the source, allowing overcurrent protective devices like circuit breakers or fuses to trip and de-energize the circuit. Secondly, the exception to NEC Article 250.24b is significant for situations where a single service supplies only one building or structure. In this case, the grounding electrode conductor does not need to be run with each feeder. Instead, it can be run with any one of the supply conductors. This exception simplifies the wiring requirements in certain situations, reducing the amount of grounding wire needed. Thirdly, NEC Article 250.104 focuses on the connection of the grounding electrode conductor to the equipment grounding conductor at the service equipment. This connection ensures that all metallic parts of the electrical system are properly grounded, providing a path for fault current to flow back to the source. The exception to NEC Article 250.104 applies when the grounding electrode conductor is connected to the neutral conductor at the service entrance equipment, and the grounded neutral conductor is effectively grounded at each building or structure served. In this case, a grounding electrode conductor is not required to run with the feeder from the service equipment. This arrangement is common in situations where multiple buildings are supplied from a single service. Fourthly, when using Ufer grounds, it is crucial to comply with NEC Article 250.52. This section specifies the requirements for concrete encased electrodes. A Ufer ground consists of at least 20 feet of bare copper conductor that is encased in concrete. The concrete must be in direct contact with the earth. Ufer grounds are very effective grounding electrodes, providing a low impedance path to ground. Fifthly, grounding the neutral conductor at the subpanels is an essential part of the grounding system. This grounding ensures that the neutral conductor is at ground potential, reducing the risk of voltage fluctuations and electrical noise. The neutral conductor can be grounded through a separate grounding electrode system at each structure or by bonding it to the Ufer ground. Sixthly, local electrical codes may have additional requirements or more stringent regulations than the NEC. It is crucial to check with the local authorities to ensure compliance with all applicable codes. Local codes may address specific issues or concerns that are not covered in the NEC. For example, some local codes may require additional grounding electrodes or specific wiring methods. Seventhly, it is essential to understand the difference between grounding and bonding. Grounding is the connection of the electrical system to the earth, providing a path for fault current to flow back to the source. Bonding is the connection of metallic parts of the electrical system to create a low impedance path for fault current. Both grounding and bonding are crucial for electrical safety. Eighthly, proper grounding helps to prevent electrical shock. When a fault occurs in an electrical system, such as a short circuit, the fault current can flow through unintended paths, such as a person's body. Grounding provides a low impedance path for the fault current to flow back to the source, reducing the risk of electrical shock. Ninthly, grounding helps to prevent fire hazards. Fault currents can generate heat, which can ignite nearby materials and cause a fire. Grounding helps to limit the duration and magnitude of fault currents, reducing the risk of fire. Tenthly, grounding helps to protect electrical equipment from damage. Fault currents can damage electrical equipment, such as motors, transformers, and electronic devices. Grounding helps to limit the magnitude of fault currents, protecting electrical equipment from damage. When installing a new 200 amp service, it is essential to follow the NEC and local electrical codes carefully. This includes properly grounding the service equipment, feeders, and subpanels. It also includes using appropriate wiring methods and overcurrent protective devices. A thorough understanding of grounding principles is crucial for ensuring electrical safety and compliance. If you are unsure about any aspect of the electrical installation, it is best to consult with a qualified electrician. They can provide guidance and ensure that the installation meets all applicable codes and standards. Remember that electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical hazards. Always de-energize circuits before working on them and use appropriate personal protective equipment, such as insulated gloves and safety glasses. By following these guidelines, you can ensure a safe and reliable electrical installation.